Good morning, everyone, and thank you for joining us for this technical webinar with IgniteNet. My name is Nicole Devereaux, Marketing Coordinator with MBSI WAV, and presenting today we have John Reiner, Technical Support Manager and Director of Training with IgniteNet. I'd like to bring your attention to the chat window, found top right of your screen. Please address either myself or everyone with any questions you may have throughout the webinar, and we'll answer them when time permits. With that said, I'll pass the mic over to John and we'll get this started.
So first, I'm going to introduce you to IgniteNet. If you don't already know, IgniteNet has offices located throughout the world with a big focus on engineering. We like to engineer 60 gigahertz, 5 gigahertz, 2.4 gigahertz solutions. We offer a complete solution with our products as well. So we go from indoor-outdoor Wi-Fi, which is 802.11, BGNA, AC, AC Wave 2. We do 60 gigahertz point-to-point and point-to-multipoint infrastructure. We even have wired access, such as our Fusion Switch product line, which is PoE switches and SFP switches. We have MeshLinq, which I'll talk about a little bit in this webinar. And then we also provide add-on apps and services and anywhere, anytime access through our IgniteNet Cloud, which is used to manage all of these solutions that we sell. So just a little bit about the cloud. The cloud is very low cost, so it's only $99 per year. And what it allows you to do is monitor your devices with statistics and alerts. It allows you to do bulk firmware and configuration. And it also, like I mentioned before, has a marketplace for add-on apps and services, which add value and allow you to produce additional revenue streams. So now I'm going to introduce you to MetroLinq. MetroLinq products operate primarily at 60 gigahertz, though they have 5 gigahertz and 2.4 gigahertz radios in some cases. 60 gigahertz is unlicensed spectrum in the US, Canada, and Mexico, which has even opened up from 64 gigahertz all the way to 71 gigahertz. If you see at the bottom of this picture, you can see that we have channel 1, channel 2, channel 3, and channel 4. Those are our current operating channels in the 60 gigahertz band. As you can see, these are very wide channels, right? These are almost 2 gigahertz each, which allows us to get a very high symbol rate, nearly 1.76 billion symbols per second. This allows us to get very high capacity with not quite as complicated modulation and coding schemes that you might see in other bands. As I mentioned, this is 7 gigahertz of noise-free spectrum total that's available, as compared to the 250 megahertz or the 500 megahertz available for 24 gigahertz and 5 gigahertz bands, respectively. The reason why 60 gigahertz, why we're allowed to have so much free spectrum here, is because the maximum interfering distance is very small as compared to other bands. As you can see in this picture, 5 gigahertz and 2.4 gigahertz go very far as compared to 60 gigahertz. So people are more likely to interfere with each other on 5 gigahertz and 2.4 gigahertz, as well as interfere with themselves. The reason why 60 gigahertz does not go quite as far is mostly due to oxygen absorption. And this oxygen absorption prevents the signal from traveling as far as it would otherwise, but it also provides the benefit of reducing the amount of self-interference, like I mentioned, and also makes it to where these products have to use very high-gain antennas and technology such as beamforming, both of which allow you to use 60 gigahertz technology and very dense urban deployments without running into the same issues that you'd run into with other bands. So now I'm going to talk a little bit about flexible bridging and the applications, just a brief introduction here. So MetroLinq is typically deployed in point-to-point and point-to-multipoint, as you can see in these pictures. Now, these topologies provide layer 2 transparent wireless bridging, and this serves a variety of applications, such as fiber extension. So if you have fiber coming in at one of these buildings here, you can easily extend it where it'd be costly to do otherwise with a point-to-point link or even a point-to-multipoint link. This applies for Wi-Fi backhaul, small cell backhaul, anything that could benefit from extending the layer 2 network. MetroLinq products also have the added flexibility of being tri-band. So every radio that is called MetroLinq is going to have a 5 GHz failover radio, even the first generation. But from MetroLinq 2.5 and on, the 5 GHz backup radio can also have additional virtual access point or service set identifiers to which you can connect other radios for infrastructure, or you can use for Wi-Fi access if you want. The MetroLinq Lightweight and the MetroLinq Omni also have a 2.4 GHz radio, which can be used for the same purposes. Another benefit of MetroLinq is that we do everything we can to make deployment quick. In addition to it being unlicensed spectrum, we also have alignment tools that you can buy, such as the MetroLinq Scope, and we have the free aiming tools, one of which is built into the GUI, and one of which is simply an app for your phone that you can use if you have a Bluetooth 4.0 dongle. I'll cover these a little bit more in a few slides. Another benefit is that we have a highly functional OS that we're constantly adding new features to. Currently, we have a highly responsive UI that's built into the device that you can access very easily. Within this UI, you can do things like set the packet size to be up to 7,900 bytes. You can turn on management VLAN. We also have some customer VLAN on some products. We also allow point-to-point master or point-to-point client modes for all of the devices. So you could really use any device as a master or a client. The one that you pick for that application will depend on what coverage you need and the distance of the link that's required. But all of them also support failover and backup, like I mentioned before, 128-bit AES encryption, and dual firmware image support. So if one firmware image bank gets corrupted because of power failures or something like that, it can always revert to a backup. MetroLinq also has powerful management. So MetroLinq can be managed, configured. Everything can be done through a local GUI. You could also use the cloud to manage it. We also support SNMP if you'd like to monitor it with your network management system. Now I'm going to talk a little bit about the MetroLinq product line. So our first generation MetroLinq, or the MetroLinq 60, was 1.4 gigabits per second aggregate throughput. It has the 5 gigahertz failover radio, as I mentioned, 2 gigabit Ethernet ports, a USB port for the Bluetooth aiming dongle, and the maximum distance, if you're using the higher gain antennas, is going to be 1.5 kilometers. The two options for this generation would be the 6035 and the 6019, which corresponds to a 35 centimeter dish for higher gain or a 19 centimeter dish for a little bit less gain and a little bit less distance, respectively. On this slide, I have a more thorough comparison of the two units. The key things to take away here are that the size for one is much smaller, and the size for the other one is much bigger. The speed is the same, the input-output ports are the same. What you're really doing here is you're trading off form factor for distance. With the MetroLinq 2.5 product line, we took the previous generation and we made the wireless much faster. We also added a 2.5 gig N-base-T port instead of a regular gigabit Ethernet port. And then we also added an SFP port if that's what you would like to use. Now, to get the full capacity that you can get in one direction, since this is aggregate throughput, you have to use the 2.5 gig N-base-T port. If you have bidirectional throughput, then maybe you can get away with just using the SFP port or using a gigabit Ethernet port connected to our N-base-T port, since it is backward compatible. The 2.5 gig 60 also has a USB 3.0 port for the Bluetooth aiming dongle. Another major benefit or upgrade with this version is that there's 24 to 48 volt DC in, so you can simply run DC power and fiber up to the site instead of running Ethernet. I'll talk a little bit more about the beamforming sector, which is shown in the table below in a second, but the main trade-offs here are the same as the other units. You've got form factor for distance. And the same thing is shown on this comparison slide. So the MetroLinq 2.5 gig beamforming sector, this adds 120-degree beamforming to the mix. So this radio is typically going to be used as a point-to-multipoint AP because it's very easy to connect multiple points to it when it has such a large coverage area. It does that by steering a narrow beam in 10-degree steps to make an equivalent of 120 degrees. This radio also has 5 GHz failover. As I mentioned, that 5 GHz radio can have additional access points or additional virtual access points to which you could connect other infrastructure clients or Wi-Fi clients. It also has, the same with the 2.5 6019 and 2.5 6035, it also has the one N-base-T port and one SFP port, has a USB 3.0 port, and 24 to 48 volt DC in. Now the MetroLinq Lightweight, this is our lower cost, so it's about half the cost of, say, the MetroLinq 2.5 beamforming sector, somewhere roughly in that area. It does 1 gigabit per second aggregate throughput. It does 600 megabits per second on 5 gig and 300 megabits per second on 2.4. The cool thing about this radio is not only is it inexpensive and lightweight, but it also has a 2.4 gig radio for supporting Wi-Fi access or additional infrastructure connections. It's actually available in 2 models, so you can get a dual band Omni version, which has a 7 dBi 5 gigahertz radio or 5 gigahertz antenna, or you can get it in the 5 gigahertz standard or the standard version, which has a more directional 5 gigahertz antenna, which is 18 dBi. In either case, the 2.4 gigahertz radio is around 5 dBi. The lightweight does up to 26 dBm output power, so you can go pretty far with it. It has as far as input and output connectors, it has a gigabit Ethernet port, an SFP port, and USB 3.0 for Bluetooth aiming. Now I'll talk about the MetroLinq 10 gig Omni, which has been the star of multiple trade shows and has been a big hit with the customers. The 10 gig Omni has what we call 10 gigabits per second net throughput, and that's because it actually has 3 120-degree beamforming radios on 60 gigahertz. So it has 3 radios at 120 degrees to cover a total of 360 degrees. Each of these radios can be configured individually, which is an added benefit. The 5 gigahertz radio is also very powerful and supports 8x8 and has 4 of these in 90 degrees. Same with the 2.4 gigahertz radio. So the Omni is a very powerful radio, similar to one of our competitors' radios actually, except with an added 60 gigahertz radio for 360 degrees coverage. The input ports to the 10 gig Omni would be a gigabit Ethernet port, a 10 gig SFP plus port, which most people would be using, and the USB 3.0 port if you want to use the Bluetooth aiming dongle. The DC input for the Omni is going to be 48 volts. So on this slide, I have a comparison of the Omni, the lightweight, and the sector. And I put this here because we're comparing the various units that you're most likely to be using for a point-to-multipoint sector. The Omni is going to give you 360 degrees, very powerful 5 and 2.4 gigahertz radios, and up to 10 gigabits per second aggregate total traffic can be going through the Omni. It's very powerful for high density deployments. We have the 2.5 gig beamforming sector, which can be used if you just want to do a 120 degree swath, a little bit smaller number of clients, but also still very powerful. And then of course the MetroLinq lightweight, which some people want to use as a client or as a point-to-multipoint sector, but can definitely serve a decent number of clients in the same way that you would use the beamforming sector or the Omni, but at a much better price point. Now, for our MetroLinq and MetroLinq 2.5 products, they use either the standard bracket or the precision bracket. Now, the trade-off when it comes to these two brackets is between your degrees of freedom for adjustment and the precision at which you can aim, and also the wind survivability. So the standard bracket gives you a very large degree of freedom adjustment. You get plus or minus 80 degrees, and you can also mount it on a wall. However, a lot of people have found for the standard bracket, it's a little bit more difficult to use for very long distance links that use the higher gain antennas. And this is because it has a little bit more give to it. However, most people find it great if they're using it for a beamforming sector, for example. The precision bracket, on the other hand, it only has plus or minus 12 degrees of freedom for adjustment, but it can survive a lot more wind, and very, very fine adjustments are very easy to make, and most people find it much easier to use this for long-range links. The alignment tools that I mentioned before include the aiming scope, which you simply mount it directly on the device, and you use it to get a course alignment, which I'll cover in a minute. The LinqAssist application, you can use that as long as you plug a Bluetooth USB dongle into the device, and that will allow you to fine-tune it after you've gotten a course alignment with the scope. So somebody asked the question, what is the max distance for point-to-point and point-to-multipoint on 60 gigahertz? So for point-to-point, the max distance that we recommend is 1.5 kilometers. You can actually get much farther if you're in a dry climate. However, 1.5 is what we recommend. For point-to-multipoint, we recommend about 1 kilometer if you're using the high-gain client to the Omni unit or the beamforming sector. Another question is, can we provide a location or client who has been using MetroLinq, MetroLinq Omni, or other point-to-multipoint? I will provide some case studies a little bit later in the slideshow to answer that question. And you're also feel free to follow up with me after this, and I can help you, or I can get you with one of our happy customers who can talk about their deployment and how they did it. I'm going to briefly talk about MetroLinq here for a minute, or MeshLinq here, sorry, for a minute. So MeshLinq is our switch that we've designed to work very well with MetroLinq, and it features something called Trill, which is shortest path layer 2 bridging and failover in an arbitrary mesh topology. Some of the main features, some of the other features of the MeshLinq switch is that it offers a standard switch mode with port aggregation, so you could use it for a seamless failover just between two links. It also has configurable passive PoE output, which can power MetroLinq devices, for example. It has an indoor-outdoor switch enclosure, so you could use it outdoors, which is what we'd expect most people to use it. It has the same configuration management and maintenance that you would see with MetroLinq, and also same SNMP capability. So this picture shows how maybe you could use MeshLinq, the MeshLinq PoE output to power 60 gigahertz backhaul, point-to-multipoint link, maybe your Wi-Fi access point, or even some surveillance. cameras. The output voltage for the MeshLinq matches the input voltage from 24 to 48 volts and can provide provide this to passive PoE capable devices, or generally to 802.3 AT/AF if at the correct voltage. So now I'm going to talk just a little bit about what we expect from the next generation of wireless networks using technology like MeshLinq that we've talked about and MetroLinq. So previously, a lot of WISPs like to find the tallest structure and shoot several miles into the city. Typically, this is done with 5 gig or maybe some other band. However, we're proposing that you can overcome a number of problems that are introduced that way by simply jumping from building to building, creating redundant multi-gigabit networks using MetroLinq and maybe even MeshLinq too in a mesh topology. One of the most popular things when people are creating redundancy in a network is to use rings, which are great for most applications, but if 2 points on a simple ring fails, then you have a complete failure. In contrast, mesh networks, like what you could create with MeshLinq, are much more tolerant because you can lose multiple nodes and still be perfectly fine. So I just wanted to show a few case studies here where people have used MetroLinq to great success. One of them has been Stephouse Networks, where they've used our point-to-multipoint Omni, and they've also used the beamforming sector successfully to get rid of some of the interference issues that they were having with their 5 gigahertz deployments. The same is true for EOT in New York City. They were having some serious issues with 5 gigahertz in New York City, as you can imagine. They had rolled out a large network and it began to fail, and the ability for them to serve their customers became smaller and smaller as more and more people were putting up 5 gigahertz radios. After switching to 60 gigahertz, those problems disappeared, of course, and they were able to serve some communities in New York City that were only able to get about 5 megabits per second service previously. Now I'm going to talk a little bit about configuration and management. MetroLinq can be configured and managed through the local GUI or the IgniteNet cloud. There are some changes that can even be made via SSH if you're Linux savvy. If the device has an internet connection, it's automatically going to reach out to the cloud, but you can tell it to not do this if you don't want it to have cloud messages in your log if you're not using the cloud. You can use the GUI and the cloud to manage the device at the same time. It won't cause any issues. So I'm going to show some slides which just show the local GUI. The first piece of the local GUI I'm going to show is the dashboard. Now the dashboard has a general status, a wireless status, and it has traffic graphs and services. So the general status is going to show you most everything you need to know about the general health of the device, and also includes Ethernet port information as well. In the wireless status, you're going to be able to see if you have a 5 gigahertz radio connection, if it's enabled or disabled, if you have a 60 gigahertz connection, and let's say you do have a connection, it's also going to show you the local RSSI and the remote RSSI, which means the RSSI received by this device from the one it's connected to, or the RSSI that the other device is seeing in the information it's receiving from you. This page also shows the local MAC, meaning the MAC address of the 60 gigahertz radio, and it will show you the data rates in live and the transmit power that you've set channel, as well as the connected time and whether or not you have security features enabled. On the Traffic Graphs tab, you can see live traffic data from any of the interfaces through which traffic is passing. On the Services tab, you'll see all of the services that are running, which might include the IgniteNet Cloud or Ping Watchdog. Some other things you can do with the GUI would be upgrading firmware manually. So it's fairly simple to upgrade your firmware manually if you want. You just go to System, Maintenance, click on the Upgrade button, and choose the file which you would have downloaded from our support site, and then click Upgrade. If you click the Keep Current Settings after Upgrade, it will keep the settings you have. If you click on that to where it is not filled in, then it will reset to defaults when you upgrade. Some other things that you can do from that system menu is view the logs for the device. You can view an entire troubleshooting log, maybe send them to support if you need help. You can reset the device. You can back up the configuration into a file, and you can restore the configuration to a file that you've made a backup of. Now I'm going to talk a little bit about configuration. So there are three menus for configuration. There's Network, Wireless, and System. In the network configuration, it's pretty straightforward. This is where you would configure your IP address, whether or not you want it to use DHCP or you want it to have a static management address. Here you could configure management VLAN if you would like to use that and separate the management traffic from all the other traffic. You can also set the MTU size here. Now I'll talk a little bit about the 60 gigahertz radio settings and how easy it is to establish a 60 gig connection. So all you'd really need to do here is make sure that one device was in master mode, one was in client mode, that they were on the same channel, that they were using the same SSID, that they both had the encryption key set. I recommend sliding the ACK timeout all the way to the right, and that's all that you would need. Some adjustments that you could make on 60 gigahertz would be the MCS rate. Now by default, the MCS rate is going to be on auto, which means the device is going to set your MCS rate based on the packet error rate, the signal strength, and the radio temperature. But if you think you know better than the device does, you can try to set this manually. You can also use client isolation, which would block traffic between the point-to-multipoint clients on the link. You can set the TX power manually. Maybe you have a short link and you need to turn it down. You can turn AMPDU on, which is always recommended because it makes things more efficient, and at 60 gigahertz there really isn't much of a latency trade-off. You can use traffic control, which will allow you to limit the traffic to each client based on their MAC address. And there's also RSSI-based failover, which allows you to set the threshold at which the device would fail over to the 5 gig backup radio. So for some 5 gigahertz settings, if you want to add additional SSIDs for MetroLinq 2.5 and beyond, you can do that. You can change the transmit power, and you can also use multicast enhancement, which basically just makes things more efficient if there's multicast traffic. Once you have made some settings change, saving, applying, or even testing the configuration is fairly easy. All you have to do is click the Save button, then click Apply or Test. If you click Test, you'll have a time limit after which the configuration settings will revert unless you apply them beforehand. Now I'm going to go into a little bit about installation and alignment. When mounting the MetroLinq device, you should choose a mounting structure that's plumb. So when you're installing the mounting structure, it shouldn't be crooked, and it should definitely be stable. This way, you don't have polarization mismatch, and you don't have the device moving out of alignment or anything like that. You should also choose a mounting structure that allows the MetroLinq to move up and down a little bit. This will be really helpful if you end up having multipath issues. Moving the device, a few feet in any direction and realigning oftentimes will completely mitigate any multipath you're dealing with, and so having a mount that allows you to do that would definitely be beneficial. You should not mount the MetroLinq upside down or sideways. Grounding. If you ground the structure to which you are mounting the MetroLinq, you should be fine. If that structure is not grounded, then you can always use the screw that's included with the ground at the ground point, and then ground that in compliance with standards. You should avoid grounding the surfaces with paint or isolating treatment. So now that you know how to install it, I'll talk a little bit about alignment. Precise alignment is going to be required between MetroLinq radios typically. If you're doing a long-range point-to-point link with the high-gain antennas, this is especially true. However, this alignment can be done quickly and efficiently if you follow a simple coarse alignment and then fine-tuning process. For coarse alignment, it's pretty straightforward. You can use the IgniteNet scope or the MetroLinq alignment scope if you have it. You'd simply attach it to the base of the MetroLinq like I mentioned before and adjust the alignment on the unit until the remote side is in the crosshairs. What this does is it gets you 90% there, after which you can do a fine tuning. Another way to get this coarse alignment might just be visually if it's a closer link without the scope, or you might be able to do it looking at the values of the 5 GHz backup connection. A lot of times the 5 gig backup radio will connect before the 60 because it has a wider beam width and 5 gig travels a little bit farther. So if you get a connection early on 5 GHz, you could dial in those signal levels, which will also get you about 90% there. Before you start your fine tuning, then you're going to want to start aiming mode or the LinqAssist app, which I'll talk about after I talk about aiming mode. So to use aiming mode, you just log into the MetroLinq client device, navigate to the 60 GHz settings page, open the aiming tool. You can set a timer here if you need to. For example, if you wanted to, if you were at the master unit in a point-to-point link and you wanted to adjust it, you could set a timer on the client, then go back to the master, and then do the aiming using the aiming mode in the master since it has already been started on the client. You should note here that it must be started on the client first. So then once you start aiming mode on the client, you'll see a bar. It'll tell you what your signal to noise ratio is and what your RSSI is for local and remote. LinqAssist is very easy to use. All you have to do is take your Bluetooth dongle, plug it into the MetroLinq's USB port. It'll automatically start doing its aiming mode process. You open the LinqAssist app after you do that and click on the MAC address or touch the MAC address if you're using a touchscreen device, which you probably will be. So you would touch the MAC address. It would take you to a page where it shows you the local and remote and combined RSSI for the link. Then you could go about doing your fine-tuning process. To fine-tune the device, you're really going to want to loosen the bolts for one axis at a time. One of the biggest problems out in the field that we see with MetroLinq is alignment, and one of the biggest mistakes within alignment is when people are trying to adjust both axes at the same time. Once you loosen the bolts for just one axis, you can sweep very, very slowly across the axis and find the point of the maximum. Once that's found, you lock down the bracket on that axis and you do the same thing for the perpendicular axis. Sometimes, for a very long point-to-point link that uses the high-gain antennas, the installer might have to do the process more than one time. If the installer is using the scope, it's also a good idea for them to take note of the final position after they're done tuning the alignment in the scope's crosshairs and see kind of where it was pointing at, just in case they ever have to re-aim it or do some maintenance on it in the future. Now, once the MetroLinq units are aligned, it's good practice to test it, especially testing it before the installer leaves the site. To simplify this troubleshooting, should you need to, it's recommended to test performance with as few network devices in between the test devices as possible. This is to say, I highly recommend using our built-in speed test utility rather than having the installer run an internet speed test when they're at the site, because the built-in speed test utility only goes across the link, and that will give you a better idea of how that link specifically is performing without taking into account the rest of the network. Using speed test is very easy. You just go to speed test from the system menu. You choose the 60 gig MAC address of the connected radio. So if there's point to multi-point, you'll have multiple options here. If it's just point to point, you'll only have one option. You can enter the packet size up to the MTU size that you've set for the device, and then you can click Start. So that's all I have for this quick technical presentation. So now if you have any questions, feel free to ask them.
John, we do have quite a few questions. Why don't I just let you know what they are and you can respond to them?
Sure.
Okay, so first question, when will MeshLinq be available to the cloud controller?
Soon is the best answer I can give right now. If you email support@ignitenet.com, we can follow up with a more concrete date for you.
Okay, great. Next question, can you comment on the PoE compatibility for the ML 2.5, 60, 19, and Cisco switches? I'm having issues powering those from a new 3560.
So the MetroLinq 2.5 series, they use passive PoE. So if you're doing 4-pair passive PoE at 24 to 48 volts, you'll be okay. I'm not familiar with that exact switch, but if it's not providing passive PoE, then you might not be able to power it because it doesn't have the intelligence to tell the switch the same things that you would see if it were a 802.3 AF or AT device.
Okay, great.
I know our switches support a legacy mode where it will do passive PoE that will work for the MetroLinq 2.5. I don't know if Cisco supports such a thing.
Great, thank you. Next question, are scopes calibrated?
No, you would need to do any calibration on the scopes yourself. Typically, they're pretty close, but like I said, they get you about 90% there. Once you learn how the scope, how that scope corresponds to a particular link, it's a lot easier to align links from then on using that scope.
Okay. Are there any other simpler and better mounting options for the MetroLinq 2.5 units? Finding it difficult to use the LR precision mount for accurate alignment.
So we have some improvements coming to the LR mount. Specifically on the horizontal adjustment, we're going to reduce the amount of play that's there. We realize that it could be reduced a little bit, so we're going to do everything we can to do that. We also have materials on our support site which explain how to use the mount. That you might find that very helpful as well for getting you past the issues you're seeing. Of course, you can always reach out to support and we'll help you to the best of our ability.
Okay, and another question, how often do you do firmware upgrades?
Our firmware updates are typically once a month. Sometimes we have a few more, sometimes we have a few less. We're currently moving to a system where we're going to have beta releases, then standardized releases, and then carrier releases, each release having an additional tier of being tested and having been proven out before it achieves that status.
Okay. Do you recommend any Bluetooth dongles for use?
Yes. Some of our distributors have these dongles. You can also find them very easily on Amazon or eBay. You could order them directly from China for very cheap. I think on Amazon or eBay they tend to be about $5 or $6, maybe $8.
Okay, and I'm also being told that you can purchase Bluetooth dongles direct from MBSI WAV as well.
Yes.
Perfect. What is the beam width of the 35 centimeter and 19 centimeter MetroLinq 2.5 units?
The beam width for the 35 centimeter unit is 1 degree, and that's half power beam width. The half power beam width for the 19 centimeter version is 3 degrees.
Wonderful. Okay, next question. Are you working on a lower cost CPE for homes in the 60 gig range?
So right now our lowest cost CPE would be the MetroLinq Lightweight, which comes in, I believe, around $300 at the moment. The range on it is a little bit less than what you might see for the 2.5 6019, for example, but it does have some other features that I mentioned.
And just quickly off of that, that would be USD, correct?
Yeah, that's in US dollars, sorry.
Okay, no problem at all. Next question. When using the LinqAssist tool, can you elaborate on why one would see a poor link budget when selecting a lower channel versus a higher channel? Example, channel 1 versus channel 4.
That's a great question. So the atmospheric absorption is not the same across all channels. In fact, it varies quite drastically. Channel 4 is the best, where you will see about 9 dB per kilometer of atmospheric absorption. Channel 2 is the worst, where you're going to see about 14 dB per kilometer of atmospheric absorption.
Awesome. When using speed tests, will that tool cause a service interruption?
No, it won't cause a service interruption. However, it is going to use a lot of bandwidth and CPU power. So I would recommend using it during times that are not your peak traffic times.
Okay, I just want to give everyone one more minute. If there's any outstanding questions, I do believe we've hit everyone's questions in the chat window. But if not, please take advantage of that. I've had one just come in a point-to-multipoint deployment. Is client ATPC on the roadmap? Clients would adjust their power automatically based on a configurable setting on the point-to-multipoint master.
So this is a feature that we've heard from a few customers, and we're looking into it, but we haven't made any firm decisions, and we don't have any sort of firm dates that we could make for this. If you would like to request this feature, feel free to email support@ignitenet.com. Request the feature. The more people that ask for it, the more likely it is to show up soon.
Fantastic. Well, that is all the questions we have now. On behalf of MBSI WAV and IgniteNet, I would like to thank you for joining us. This webinar has been recorded, so we will be posting that as soon as it's uploaded, and I will share that all via email. Thank you, everybody. Have a great day.